Okay, part 2. Let's try to finish these up. Alright, so in this next one, I see R3 and R4 are in series with each other, so you can add those and you'll get 10 ohms for those two. And then that 10 ohms is parallel with R2, so you can add those in parallel and we should get 3.33 ohms. And then that 3.33 is in series with R1, so you just add that and we should get 6.03 ohms. That 2.7 is probably rounded in there, so this is probably supposed to be 6 ohms. We'll just go with this. So Ohm's law, V equals IR, so our total current 1.99 amps. So I've got 1.99 amps right here. Anything in series with the battery is going to have that same current, so I see R1 1.99 amps. V equals IR for R1, should get 5.37 volts for that. You know, again, we look at the current, 1.99, some goes this way, some goes this way. I don't know how it's split, so I'm going to go look at the voltage now. So I'll do red again, that's my go-to. So red for this inner loop. Alright, and we can look at that voltage for that loop. The battery, we start out with 12 volts. And then we lose some voltage through R1, and that's 5.37, so minus 5.37. Then we're going to lose more through R2, and then that's it. For that red loop, we are done, so we need to be down to 0. So R2, the voltage, we should get 6.63. Okay, and then V equals IR for that gives us 1.33 for the current. Now this one, I'm going to go back to current here. All right, we have we know we have 1.99 amps coming through here, 1.99 amps, and then we just solve for the current here, which was 1.33. So then the rest of the current, I'll call this I3, has to go this direction. So using the junction rule, the current going into the junction, 1.99, and I'm looking at this junction right here. 1.99 is the current going into the junction, has to equal the current leaving the junction, which is 1.33 and I3. So we solve that for I3 and we get 0.66 amps. So I3 right here, 0.66 amps. There's no junction throughout here, so that means this whole branch has a current of 0.66 amps. 0.66, 0.66, and then we can do V equals IR for 3 and 4. We should get 3.96 volts here, 2.64 volts here. Now again, you know, don't rely on the voltage adding up to the total. Don't rely on the current adding up to the total. Don't rely on the resistors adding up to the total. The only thing you can count on is power. So I'm going to use one of the 3 power equations. Usually IV is the popular one because you're not squaring anything. You're just multiplying I and V. So solve for each of the powers. 10.7 watts, 8.8 watts, 2.6 watts, 1.7 watts. And then even here, I'm going to get 23.9. Double check, do the individual powers pretty much add up to the total with some rounding in there? Looks like they do, so we're done with that one. Okay, number 5. First thing that jumps out at me is these 3 resistors are parallel with each other. So I'm going to add them in parallel, and I should get a total of 9.23. When those are added in parallel, I know, what is it, 2, 3, and 4. I know it's going to be less than 20 because remember in parallel your total resistance is less than your smallest resistor. Now that 9.23 is in series with R1, so we can just add those and we should get 19.23 ohms for the total. V equals IR should give us 4.68 amps for the total current. 4.68 amps. Anything in series with the battery will also have 4.68 amps, so I've got that right here. And then V equals IR, so 46.8 volts for R1. Okay, now here we've got the 4.68 amps comes to this junction. It splits 3 ways. I don't know how much goes to any of the branches, so I'm stuck on that. I'm going to look at voltage. I'm going to go with green now. So I'm going to take a loop that goes through R1. I'm just going to take the outer or the upper one there. Okay, so in that loop I have to lose all 90 volts, which is what I'm starting with at the battery. So I start with 90. I'm going to lose 46.8 through R1, and I'm going to lose more through R2, and I should be back at 0. So if I solve for V2, I should get 43.2. 43.2. V equals IR for R2, and this should be 2.16 amps. And at this point, if you can recognize, let me try some other colors here. You know, if we take the blue route, which is going to go through the middle one, or we'll go to the red again. Red, which is going to take this lower route through R4. It's kind of a mess there, but if you just look at one color at a time, the only difference, they all go through R1, and then green goes through R2, blue goes through R3, red goes through R4. So it doesn't matter which path you're taking. If you start out with 90 volts and you lose 46.8 here, no matter which path you take, you're going to lose 43.2 in any of the other resistors. So I can right now call this 43.2, 43.2. You can do the loop rule all over again, set up an equation for the red and the blue, you're going to get the same answer. I'm just trying to show you a couple different ways to look at these. So V equals IR for these, I get 1.44 amps for that one, 1.08 amps for that one. Solve for all the powers going across, I get about 219 watts here, 93.3 watts, 62.2, 46.7, and then again going across, I'm going to solve for that power, 421.2. Do the individual powers add up to the total? Yes, they do, so we're good. All right, number 6. Okay, looks like this guy's not labeled, but anyway, that must be R5. 1.5 ohms. So first thing that I see is 3 and 4 are parallel only with each other. So I'm going to add 3 and 4 in parallel. I should get 1.5 ohms for that combination. And then that 1.5 ohms is in series with R5, which is another 1.5. So this whole branch here is going to be 3 ohms. Okay, because this is 1.5. Now I've got 3 ohms parallel with R2. Okay, so the 3 ohms parallel with R2, which R2 is 6. I think we get 2. I don't have that written here. But you add those in parallel, and then whatever you get here, add that to R1. Yeah, you do get 2. So when you add the 3 ohms here, parallel with R2, you should get 2 ohms. And then that 2 ohms is in series with R1, which is 4 ohms. So anyway, our total resistance is 6 ohms there. Okay. V equals IR, total current 1 amp. 1 amp, which means R1 is going to have 1 amp. Anything in series with the battery is 1 amp. And then V equals IR, so 4 volts there. Okay, now that 1 amp splits, some will go this way, some will go this way. I don't know how it splits. I'm going to look at current. All right, so I'm going to do, let's get some bears colors in here. Okay, so I'm going to go through this loop. Okay, that loop goes through R1 and R2 only. I start with 6 volts. Battery is 6 volts. I'm losing 4 volts in R1, and then I lose some in R2, and I should be down to 0. So then V2 must be 2 volts. Okay, V equals IR, so then the current here is 0.33. Right? Now we can look at another loop. Again, bears colors. Okay, so we're going to go this. Oh, I thought I clicked that. Hold on. Okay. All right, so I'm going to go through R1, and then I'm going to go through R3, and then R5, and back to the beginning. Well, if we try to do this, you know, we start with 6 volts, we lose 4 in R1, and then we lose some in R3, and then we lose some in R5, and we're down to 0. We've got two unknowns there. Okay, so we're kind of stuck on voltage. I have to go back to current. All right, this is going to get a little messy. I'm going to look at current. Give me a bright red for current. Okay, so current, I'm going to look at this junction right here. Current going into the junction equals current leaving the junction. So the current going in is the current going through R1, and that is 1 amp. So that's the current in. Current leaving, we've got some going this way, which is 0.33. And then we've got some going the other way. I'm going to call it I5. You'll see why in a minute if you don't already. So then I5 equals 0.67 amps. Okay, so the 0.67 amps goes here. It's going to split. I don't know how, but it will come back together. So the current here is going to be 0.67 amps. So now that is 0.67, and then the 0.67 again is going to join up with the 0.33 to make the 1 amp. So it all works at both junctions. Okay, so then this voltage is going to be about 1 volt. And then if we're looking at current, we don't know how the current splits. Let's go back and look at voltage. Okay, so I'm going to go back to I think I had this blue. Okay, to this equation right here. Okay, now we know what V5 is. So I've got 6, which is what I started with, minus 4 minus V3 minus V5. Well, that's 1 equals 0. So then V3 must equal 1 volt. Okay, and then V equals IR, so this will be about 0.16. Oh, wrong number. So about 0.16 amps. I'm a little messed up on my rounding right now, so my math might not be exact. But R4 is parallel with R3, so I know that also will have 1 volt. And then with its resistance of 2, that will be 0.5 amps. Okay, so we've got it all done. Solve for the powers. We should have 4.66 about 0.16, 0.5, 0.67, and then 6 total should add up. We should be good to go there. All right. Let's stop here. I'm going to run out of time again on this one. I'll do a part 3 just to finish up this last one. I don't want to rush through it. All right, hold on.